All right, today we're diving into the pretty surprising world of aerosol technology. We're going to break down how the exact same scientific principle can power two wildly different things. You know, the can of hairspray in your bathroom and the super high-tech system that protects a whole server farm from catching fire.
So let's just jump right in with a question that gets to the heart of it all. I mean, on the surface, these two things seem like they have absolutely nothing in common, right? But as you're about to see, they actually share a single, brilliant technological ancestor.
And here's the answer. They're both aerosol systems. Now, when you hear aerosol, you probably just think of a pressurized can, but the definition is actually way broader. At its core, an aerosol is just any system that suspends tiny particles, could be liquid, could be solid, inside a gas. And that simple principle is the key to everything we're about to cover.
Okay, so let's start with something we all know, the regular old consumer spray can. We use them for pretty much everything, right? Cooking spray, deodorant, but have you ever really stopped to think about how they actually work?
You know, what's really interesting here is that not all spray cans are created equal. The chemistry inside changes completely depending on what it's supposed to do. In air freshener, for example, that's usually a solution system. Everything's just dissolved. But for something like, say, a dry shampoo, you need a suspension system that can keep those little solid powder particles all mixed up and ready to go.
The secret sauce that makes all this possible is pressure, a lot of it. A typical can is built to handle up to 180 pounds per square inch. And to put that into perspective for you, that's about 6 times the pressure in your car's tires. This intense pressure is created by a chemical called a propellant, which is just desperate to expand into a gas. And the process itself, it's a beautifully simple piece of mechanical engineering. When you press that button, you're really just opening a tiny valve. That huge pressure from the propellant instantly shoves the product up a little plastic tube and out the nozzle, where it atomizes into that fine mist we all know. It is all about propulsion, getting something from inside the can out.
Okay, so now let's pivot. We're going from everyday convenience to critical, life-saving safety. We're about to see how that same aerosol principle gets used not to push a product out, but to stop a chemical reaction, fire, dead in its tracks. And this is where the technology gets truly fascinating.
So, unlike a spray can, a condensed aerosol fire suppression system isn't under constant pressure at all. It just sits there, completely inert, until it's called into action. Its job isn't mechanical, it's chemical. It's designed to literally attack the fire itself, interrupting the chain reaction that lets stuff burn.
And it attacks that fire using these incredibly tiny particles. We're talking less than 2 microns in size. That's smaller than a single human red blood cell. It's this cloud of ultrafine particles that floods a space and gets to work on the flames at a molecular level. It's pretty amazing.
And this just shows you the difference so clearly. This isn't about you pressing a button. Instead, a smart sensor detects smoke or a big spike in heat. That sends an electrical impulse to a generator. This ignites a solid, almost brick-like compound inside, triggering a super-fast chemical reaction that produces a cloud of potassium salt particles. These particles then just flood the room and chemically break the fire's chain of combustion, putting it out in seconds.
So you've got a mechanical propulsion system on one hand and a chemical suppression system on the other. Let's put them side by side to really hammer home just how different their design and purpose are, even though they're both technically aerosols.
The really crucial point is right here in the details. For a can of hairspray, engineers are worried about stuff like the formulation and the packaging. For fire suppression, they're calculating the exact volume of the room and how dense the agent needs to be. And the safety standards? Worlds apart. A spray can might just need a flammability warning. A fire system has to meet these super strict standards, like NFPA 2010, and prove its particles can hang in the air for at least 10 minutes to make sure the fire doesn't spark back up.
It all boils down to this fundamental difference in what they're trying to do. One system's entire reason for existing is to get a product out in a convenient form. The other's is to terminate a dangerous self-sustaining chemical reaction. I mean, two completely different missions, both born from the same basic scientific idea.
So, what's the big takeaway from all this? What does looking at these two very different technologies really tell us about the future of this pretty simple principle? Well, it just goes to show you that the most fundamental scientific principles can have the broadest and most incredible applications. The idea of suspending tiny particles in a gas is pretty basic, right? But how you use it can range from the simple convenience of hairspray to the high-stakes, life-saving intervention of a fire suppression system. And that leaves us with one last fascinating question. We've seen this one technology used for personal care, and we've seen it protect mission-critical infrastructure. So where else could it go?
What other complex problems could be solved by this simple, elegant principle of just suspending tiny particles in a gas? It really makes you wonder.